Example 16.7 E and F gives us two new functions, and we're supposed to analyze the discontinuities from their equation. The first one here, f of x is x plus 6 over x squared plus 2x minus 24. I'm going to rewrite the denominator in factored form. That's going to result in, let's see, x plus 6 times x minus 4. And that would lead me to two discontinuities. The domain of my function will be negative infinity to negative 6, union negative 6 to positive 4, union 4 to infinity. So we'll substitute in negative 6 as well as substitute in positive 4. So when we substitute in negative 6, I'm going to find it to be a little easier to substitute into the factored form. I'm going to write it as negative 6 plus 6 over negative 6 plus 6 times negative 6 minus 4, because that's going to end up showing me that I have 0 over 0 times negative 10, which is going to result in 0 over 0, and that is indeterminate. For f of 4, if I substitute in there, again I'm going to use the factored form. I'll have 4 plus 6 over 4 plus 6 times 4 minus 4. And that's going to result in 10 over 10 times 0, which we'll just call 10 over 0. And that is undefined. So the undefined result tells me vertical asymptote located at x equals 4. The indeterminate result tells me that there's going to be a hole located at the ordered pair negative 6 comma something. So to find the y value, let me go back to the factored form, cancel out the x plus 6 in the equation, giving me 1 over x minus 4. And then let me reevaluate f of negative 6. Using that simplified equation, we're going to have 1 over negative 6 minus 4, which is going to result in negative 1/10. So that gives me the exact location of the hole, and of course it also gives me the second of my discontinuities. And we'll do this one more time. We have x squared plus 2x minus 24 divided by x plus 6. So all I've done here is just swapped the numerator and denominator. It's still a rational function, and well, actually I don't really need to factor it because I can already tell you that there's just one discontinuity with negative 6. So I can go straight to saying that the domain of h will be negative infinity to negative 6, union negative 6 to infinity. And plugging in negative 6 is going to end up resulting in 0 over 0, which is indeterminate. So you can calculate that and verify for yourself that you are going to get 0 over 0, but the point here is that we understand what that means, and what it means is that there's going to be a hole. So there's going to be a hole located at negative 6 comma something. Now I didn't have to factor the equation in order to get to this point, but now that I have an indeterminate result, I really do need to look at the factored form so that way I can check for any factors that will cancel. And the x plus 6's will cancel, which is going to leave me with just the equation x minus 4. And x minus 4 can now be used to reevaluate h of negative 6, and that's going to give us negative 6 minus 4. So now we have negative 10 as the y value to go with negative 6, and that represents our hole. It's the only discontinuity for H.